All right, you guys, next we are working on perpendicular lines. You're going to find the same thing. We're going to be comparing slopes to find patterns of lines. So we're going to start with this graph, and we're going to see if we can find an equation for line A and B, and then see what we notice about the two slopes. So I noticed that in line A, down here in red, I have a slope down 1 over 4 of negative 4. So my equation is y equals negative 1/4 x. My y-intercept is down here at negative 1, so y equals negative 1/4 x minus 1. And for line B, what I notice is that my slope is up 4 over 1, so y equals 4x, and my y-intercept is up at 3, so y equals 4x plus 3. Let's take a look at those two slopes and see what we notice. The slope of the red line is negative 1 over 4. The slope of the blue line, I'm just going to write it as 4 over 1, my rise over my run. Do you notice anything about these two slopes? They look like they're the reciprocal. However, one is negative and one is positive. So what we say about the slope of these two lines, and since they form a right angle here, they are perpendicular, the slope of a pair of perpendicular lines is always going to be what we call the negative reciprocal of each other. The negative reciprocal. It makes sense. 1 over 4 and 4 over 1 are reciprocals, but one is negative and one is positive, which is why it gets its name the way that it does. All right, let's take a look at another example. A is going to be an easy one to write because I see an easy to read y-intercept. The slope of A is 1, 2, 3, 4, 5, 6, 7, down 7 over 2. So y equals negative 7 halves x, and I've got a y-intercept up there at 8. Y equals negative 7 halves x plus 8. Notice that on B, I don't have an easy to read y-intercept, so I'm going to have to use point slope to get into slope intercept. So we're going to need to do some transforming. So let's start with finding the slope of this line. The slope of line B, it looks like we're going up 2 over 7. So we have a slope of 2/7, and I'm just going to pick one easy to read point over here at negative 1, 1. So I'm going to do a point at negative 1, 1. If I know the slope, I know the point, I can easily write an equation in point-slope form and use that as a pathway to transform to slope-intercept. Here's what we've got. Y minus 1 is equal to 2/7 times the quantity of x plus 1. We're going to distribute. Y minus 1 is equal to 2/7 x plus 2/7. And let's isolate that y. And here's what we've got. Y is equal to 2/7 x plus 1 and 2/7. And that's the equation in slope-intercept form of my blue line. Let's compare the slopes. The slope of the red line, negative 7 over 2. The slope of the blue line, positive 2 over 7. I'm looking at what these form on the graph, and I see a right angle, so I know these are perpendicular. Perpendicular lines, again, their slopes are the negative reciprocal of each other. So you can pause and go back and forth so that you can make the graphs and take good notes on it. I'm going to move forward now. All right, some important things to have in our notes. We know that two lines are perpendicular, as we said before, if their slopes are the negative reciprocal. When you have two numbers that are the negative reciprocal of each other, you're going to see that the product of their slope is negative 1. If I pull the slopes from the first example today, I knew that the slope of my first line was negative 1/4, and the slope of my second line was positive 4 over 1. And when I take these two slopes and multiply them together, I can see that they have a product of negative 1. Negative 1/4 times positive 4 over 1 is equal to negative 1. If I do the same thing for the second graph, I had a slope of negative 7 over 2, a slope for the second line of 2/7. when I multiply these out, I see that the product is equal to -1. So this is just a nice thing to do to check and make sure that your slopes, if your lines form a right angle, actually, if you multiply them together, you'll end up with a product of -1. You should know, this makes a lot of sense, if you have a vertical line and a horizontal line, obviously, any vertical line is always going to be perpendicular to a horizontal line. So if I have an equation like x equals -1 and an equation like y equals 3, I know that x equals -1 is going to look something like that. Y equals 3 is going to look something like that. Of course, they're going to form a right angle. So these will be perpendicular. All right, next. We're just going to right now see if we can find the slope of a line perpendicular to each of these equations. Okay, so I know that the slope of this current line here, y equals 3x plus 1, the slope here is 3. The slope of a line that's perpendicular to 3 is going to be the negative reciprocal of 3, or 3 over 1, which is going to be -1/3. The slope of this line here, y equals 2/3 x minus 3, 2/3. Its negative reciprocal is going to be -3 over 2. All right, and here's one of these challenging ones. I'm going to do to find the slope, the opposite of a over b. So the opposite of 3 over 4 is going to be -3/4. A perpendicular line is going to have a slope of +4/3. So being able to find the slope of a line perpendicular is going to be key for the next part of our lesson today, which is going to be writing equations for perpendicular lines. Same thing like what we were working on in the last video with parallel lines. So here's what you're going to see for directions. Write an equation for the line that contains 0, -2. So you'll be given a point. And then you'll be told that it's either going to be parallel or perpendicular. In this case, we're talking perpendicular to y equals 5x plus 3. So our first step is going to be, what's the slope of our new line? Well, I'm looking for a line that's perpendicular to a slope of 5. So the slope of my new line is going to be the negative reciprocal of 5 over 1, which is -1 over 5. My point here is 0, -2. Well, 0, -2, I happen to know is on the y-axis, which means I already have the y-intercept, which means in this problem, I don't need point-slope form because I should be able to go straight to slope-intercept for this problem. So if I have a slope of -1/5 and a y-intercept of -2, I should easily be able to write an equation for a perpendicular line to y equals 5x plus 3. Here it is. Y equals -1/5 x minus 2 or plus -2. Easy, easy, especially because we have the y-intercept here. What if we're not given the y-intercept? What if we're just given a point and we need to use our other steps, point, slope? So same thing here, perpendicular to y equals 3/4 x plus 1. The first thing I want to do is identify the slope of my new line. The negative reciprocal of 3/4 is going to be -4 over 3. I'm using the given point, 1/8, and now I'm going to write my equation in point-slope form so that I can transform it into slope-intercept to finish it. Here we go. Y minus 8 is equal to -4/3 times the quantity of x minus 1. Let's do some distributing. Y minus 8 is equal to -4/3 x plus 4/3. I like to add a step here. I happen to think it's easier if I have an improper fraction and I know I'm going to be adding or subtracting an integer to it, to rewrite my improper fraction as a mixed number. It just makes it easier when you know you're going to be adding to it to do that math. So y equals -4/3 x plus 9 1/3. Having an answer like 8 4/3, it's just not the way that we want to do it, okay? So I highly recommend, if you're in a situation like this, that you change an improper fraction to a mixed number so that you can add on to it. Here we go. Here's our equation of a line that is perpendicular to the given equation y equals 3/4 x plus 1. Notice the slopes are the negative reciprocal of each other. All right, you have all the tools that you need now to complete the homework for tonight, and I will see you all tomorrow.